I'm Dr. Harsh Verma, Vice President for Global Innovation and Head of IoT Group at R Systems and an Intel innovator. R Systems is a global software company, SCI CMMI Level 5, PCM Level 5, ISO 9001, and ISO 27001 accredited. I also have the opportunity to be the chairman of ACM Sacramento chapter. And it's exciting today to take up this session on insights on AI and machine learning for IoT. This session is part of track 1, developing IoT solutions for a connected, smart, and autonomous world. And I'm excited to pull out this Movidius neural compute stick that I have with me, which I'm using to build up a neural network. So this is exciting times. Let me switch over to my presentation. This session is on insights on AI and machine learning for IoT. Just a quick about me, winding road. I'm an engineer from BITS Pilani in India and master's and PhD in computer science with my management from IIM Ahmedabad. My passion for intelligent transportation systems took me to MIT post-research, where Professor Moshe Ben Akiva was building the ITS lab on intelligent transportation systems, a collaboration with UC Berkeley's California Center for Innovative Transportation as part of the California PATH program, and an ongoing right now engagement collaboration with UC Davis. I have also done my management program from Stanford University. Quick overview about R Systems, we're a global software services company, CMM level 5, PCM level 5, ISO 9001 and ISO 27001 certified with about 2,500 employees worldwide. And you can see more if you'd like at a later time. So this session is about AI and ML for IoT, the coming era for AI and machine learning. A quick definition of what is artificial intelligence. AI is the capability of a machine to imitate intelligent human behavior. This term was given by John McCarthy back in 1956, where he proposed the term of artificial intelligence. And since then, it has really caught on. So a quick about AI. What is narrow or weak AI? We already see intelligence exhibited by machines. Expert systems that match or exceed human intelligence in a narrowly defined area, but not in broader areas, are some examples of weak AI, like GPS navigation systems, Siri, Alexa. They are all weak AI examples. Today, we are talking of machine learning, and according to Tom Mitchell, a computer program is said to learn from experience with respect to some class of tasks, T, and a performance measure, P, if its performance at task T, as measured by performance, improves with experience. So that's what is becoming a very hot topic, the machine learning, where machines will be able to learn and go beyond the weak AI examples. We already see AI in our homes. Amazon uses AI to power Alexa. Alexa, do you know about AI?
Dinosaurs are a diverse group of reptiles that...
So, sorry about that. I just wanted to give you an example. Alexa gives something else, So that's weak AI. And Alexa will keep talking now if I don't ask Alexa to stop. Alexa, please shut up. Google search engine and Google search assistant uses AI heavily. Apple uses AI. Microsoft uses AI. And Facebook uses AI to targeted advertisements and photo tagging. So, but there are two types of AI, rule-based AI and data-driven AI. Rule-based AI are basically constructs using the automatic ruled inferences and based on a set of initial data and rules and procedures that are provided by human beings, that are provided by programmers. So they can never grow beyond the intelligence of the creators. Data-driven AI, on the other hand, can measure, understand, and take decisions based on previous data, which goes on increasing. So data-driven AI can become more intelligent than its creators. So AI, machine learning, and deep learning. AI is a technique, as we saw, that enables computers to mimic human intelligence. Machine learning enables machines to improve at tasks with experience. So, if we start training these machines to learn with experience, they will build up in their expertise and capabilities. And deep learning consists of algorithms that permit software to use AI neural networks and train itself so they can perform tasks more efficiently. So as you can see, big data, which is going on increasing, is one super circle. Data mining and data science is becoming a new term. And artificial intelligence is this larger circle of which machine intelligence is a subset, and deep learning is a very specialized subset of machine learning. So training steps for machine learning, as you can see in this example, where I'm just giving a quick understanding of how machines learn by performing kind of linear regression. Let's say you wanted to know what would be the price of a house. So you provided a data set, you create a model, you provide a data set, and you provide information on, the areas, square feet areas of houses and the prices. And then you perform a linear regression to kind of estimate or, extrapolate what could be the price of a house given a particular square foot area or in a particular location. So these are the training steps for machine learning. And today we are definitely getting into the age of identifying how we can build convolution neural networks. CNNs are approximating the response of individual neurons in the human brain. So a lot of research in the human brain shows that, basically it consists of neurons, and these are layers, and you can move from one layer to the other layer. A CNN consists of an input and an output layer, as well as multiple hidden layers. And the convolutional layers basically apply a convolution operation to the input layer and pass the results to the next layer. So, it could be, for example, a layer which is identifying the color of objects, identifying the shape of objects, identifying if the object has four legs, has wheels, and thus distinct layers transform the information from the input side to the output, and given an image of an object, whether it's a dog or a cat, a person or a fruit, a car, the inference engine will be able to accurately predict what the object is with a certain degree of accuracy. So this is what is becoming exciting. It's been there for some time, but the supercompute capability which is going on increasing now is what is making CNN so exciting. So some of the toolkits for AI and machine learning that we see today, from the open source frameworks, you see tools like Spark, TensorFlow from Google, Caffe, Torch. These are toolkits driven by academia and industry for scripting and training the machine learning algorithms. So, they could be a linear regression, they could be a training set, and you basically create a script and provide a training for the machine learning algorithms. Intel Math Kernel Library, Intel MKL, is a high-performance math primitive set of libraries which provide an ability to have high-performance compute capability. The Intel DAL Data Analytics Acceleration Library is another set of data analytics acceleration objects which provide support distributed machine learning at the algorithm level. And finally, TAP, Trusted Analytics Platform, is an open source single platform which supports data science to application development. So mostly you would be moving a lot of data to the cloud, and you could have inference or machine learning at the cloud level. But today, you want to see processing at the edge. How do you get processing at the edge? Various architectural patterns, including fog and edge computing, are being proposed to localize some of the processing near the IoT sensors. So let's take a look and see what's there. Intel has announced the Movidius neural compute stick, and that's what I had in my hand, which I pulled out from my setup over here. It's very exciting. Intel acquired Movidius, and the Movidius neural compute stick enables rapid prototyping and deployment of neural networks. So it has a very low power VPU vision processing unit architecture, which enables development of inference applications at the edge. So processing at the edge takes away the dependencies of the cloud and communications network bandwidth. So otherwise what would happen is you have to send data from the edge to the cloud and then wait for processing to take place at the cloud and then get the data inference back. Now you can do the processing inference at the edge itself. So this is very exciting, and we are really looking forward to seeing what can be built up with the Movidius neural compute stick. So to run the Intel Movidius NCS, you require Ubuntu 16.04 and the neural compute SDK. NCS plugs into the USB port, and there's a lot of information at the NCS forum, GitHub, and the NCS application zoo. I will not talk too much about the NCS and how you would run the NCS. There were two wonderful sessions yesterday by Ashwin Vijaykumar and Geeta Chauhan, where they talked a lot about the neural compute sticks and the complete architecture and how you would be able to set up and create and train a model. And training datasets are also available. So do look up developer.movidius.com/start and see how you can start learning with the Movidius NCS. Here's a quick overview and the workflow of the NCS, where basically you create a model initially and then you train the model. And with the trained model, you can add your data, profile, and tune and compile and create your prototype. So, and then that way you can get the inference from the edge itself using the NCS. The NCS can be used in a laptop which has Ubuntu or even on some of the Raspberry Pi. So we are looking at such exciting prototype development. So now that we have an idea of IoT and machine learning, and particularly the Intel Movidius neural compute stick, let's look at how IoT is transforming our lives. There are some numbers which say there are 50 billion connected devices that we will see by 2020. These numbers have kind of become a little bit more conservative, and they've come down to about 30 billion. Well, still, it's a large number, 30 billion connected devices around the world, with a potential of 11.1 trillion a year by 2025 in global economic impact, according to McKinsey Global Institute. This, however, still shows that less than 1% of data is currently being used. IoT is all about sensors and data, but still you have a lot of potential since only 1% of data is used. And what is used right now is mostly for alarms or real-time control. There is a lot of potential for optimization and prediction. And once you have prediction, then you can have prescriptive analytics as well. So this is very exciting. Going to the next slide, we look at value potential of IoT. And again, this information is from McKinsey Global Institute, which shows a cross-sector view of a total potential for IoT, an impact of 3.9 trillion to 11.1 trillion per year in 2025. So I'm going to take a small break and request you to look at this chart and post into your chat box which areas you think will have the maximum potential for IoT? As you can see, this represents a number of sectors, right from home, office, factories, retail environment, work sites, human health and fitness, logistics and navigation, cities, public health and transportation, vehicles, autonomous vehicles, condition-based maintenance. So if you look at this, what is your thought? What is your opinion? Where you would see the maximum potential? As I can see myself looking in this chart, the factories have the highest potential, and very rightly so. We call the IoT with another term, which is called as industrial IoT, IIoT, and really it's called as the next revolution, right? So factories will have the maximum potential for IoT. The next one is cities, public health, where you'd go up to $1.7 trillion. Human health and fitness. There is a lot of interest in the vehicles, autonomous vehicles, and autonomous transportation, which is going to be the next wave for application. So I am looking forward to seeing your responses in the chat box, and we'll look it up later. Again, going deeper into areas where IoT creates value. As you can see, these sectors that we saw with the setting for human, home, retail environments, offices, factories. What are the areas or examples where IoT applications can imply use of AI and machine learning? Devices attached to a human body, where you can have wearables, and you can do a lot of disease management. AI is helping to identify cancer research. Buildings where people are living, you have intelligent buildings. Retail environments where systems can provide intelligence in customer relationship management. Office spaces, energy management. Factories, of course, will have a huge utilization of IoT, and again, building up AI, where you can have a lot of prediction and prescriptive analytics. So work sites, vehicles, cities, outside environments, in custom production environments, mining, oil and gas construction areas, systems inside the vehicles, inside the car itself. You have a lot of IoT. In urban environments, in cities, you probably see a lot of build up, and that's what the world is looking at smart cities and smart urban environments, where you see a lot of the demonstration of IoT. So let's see, how we apply this AI and machine learning in IoT. You'll find that IoT is going to generate billions of petabytes of data, moving between cloud and edge devices. And so naturally, rather than moving the data continuously, images and videos of data between the cloud and edge devices, if you perform edge processing and you have the potential for AI and machine learning at the edge, it is a better utilization of the infrastructure. What are the visionaries saying on AI? What are the visions and contradicting opinions on AI? As you can see, as most of you have heard on CNBC, Elon Musk, the CEO of Tesla, has predicted that AI is a fundamental risk to the existence of human civilization. And that's a very strong opinion. He has founded OpenAI for safe AI. And he's also founded Neuralink, on the other hand, to merge human brains with machines. So this is very interesting, and it does open up another side of AI. Could AI be a risk to the existence of human civilization? Mark Zuckerberg, CEO of Facebook, on the other hand, is very optimistic on the applications and benefits of AI And as you know, Facebook uses AI for a number of purposes like targeted advertising and particularly image recognition and face tagging. So these are the contradicting opinions on AI from Silicon Valley. Brian Krzanich, the CEO of Intel, himself has predicted and talked of autonomous driving and AI in the use of autonomous vehicles. Autonomous driving will end human driving errors and lead to safer roads for everyone. This is one of the biggest promises of AI, driverless future. Today, nearly 1.3 million people die in road crashes worldwide every year. And this is an average of about 3,000 plus deaths a day, per day. Nearly 90% of these collisions are caused by human error. And so use of AI and use of machine learning in building up capabilities for self-driving cars and autonomous vehicles will really save lives. And I think this is the biggest promise. I agree. So let's take a look at AI in self-driving cars and autonomous transportation, as this track is again all about autonomous world. We have all seen the Google self-driving car, which is really driving at level 5, at the highest level of autonomous driving. And AI in self-driving cars is today qualified as a legal driver. The National Highway Transportation and Safety Administration has put out the regulation that the AI system in a Google self-driving car is legally now a driver under federal law. So this is quite a bit, and this means a lot for AI. Without that, a car could not have a DMV license. So now the self-driving car has a license. Of course, it has a lot of implications. It's probably like a baby, and that's what it should be considered. It is at a handicap level. There could be other bullying cars, and so there will be a lot of implications, but this is a great start. And we are going to see AI in a number of car manufacturers demonstrating this capability. For example, Ford invests in buying a new AI software company, Argo AI. Ford is investing heavily into AI. Google self-driving cars, where Waymo has initiated and is collaborating with Intel. This is already announced. Tesla is using AI. And despite the fact that Elon Musk, the CEO, says that AI will have a dark side, he also predicts that AI will let the cars predict your destination, where you want to go at a particular moment. This means that the car will have a lot of tracking and intelligence built into the car itself. BMW has announced that it will have an Intel Xeon server-grade processor. And so this is really there. AI and machine learning have arrived, and IoT and autonomous world will not work without AI. So what are we going to do and looking at? I'm just going to now give a quick overview of what we are looking at here in Sacramento, in the state of California, a little bit of a vision setting and what is called as the ATOS Lab. Louis Stewart, the Chief Innovation Officer in the city of Sacramento, has announced the core mission of Sacramento as a real-world test zone with the opening up what they call as an Autonomous Transportation Open Standards Lab. This is in partnership with the Sacramento Kings, and the potential future will see networked vehicles and connected city, where autonomous cars will be able to drive, at least an autonomous shuttle will be able to drive people from the airport to downtown Sacramento. And this effort is being led by the city and the Kings and other industry partners as well, to build up pilots, workshops, and look at next-gen technologies. So we are looking at people sense along with the autonomous vehicles and autonomous transportation, and a quick overview of how we feel we would be able to use the Movidius NCS in such a kind of an environment for the ATOS autonomous transportation open standards, where we are building up the Sacramento People Sense trials. Right now, undertaking this signal sensing, where the signals sensed people counts via the Intel NUC gateway through a secure connection to the AWS cloud and to a dashboard for People Sense overlaid on Google Maps. So this provides a picture of people counts in the city of Sacramento. And now if we want to apply edge processing at the edge, so we bring in the Movidius neural compute stick at one of the sensors, and for the next few months, we hope to gather data. As you know, Movidius has been just announced and it's just been there a couple of months, and we hope to look at very interesting results as we create models and train the system and gather data at these trials for the ATOS operations. So this is exciting times. We are very excited to look at how Movidius NCS could demonstrate at the edge for autonomous world. So going on to the other side, dark side of AI, while definitely AI has a lot of potential, we cannot underestimate the dark side of AI, where people could use AI for bad purposes. The question is, can super AI eliminate humans? And if I'm sending data to and fro continuously from my IoT sensors and back to the cloud or back to dashboards where people are viewing information, how can we eliminate negative attacks from hackers? And how can we eliminate efforts of super AI taking negative turns? How do we manage uncontrollable AI? The solution is basically to build up more and more on encrypted deep learning, build a super intelligent AI to detect and cure cancer, for example, but encrypt it so that it cannot replicate itself, and nor can it be used without human control. So this is an example of how researchers are exploring how you can use encryption to control and have a more controlled environment so that AI does not go out of control. Encryption prevents it from being stolen by a malevolent player, and only permit a limited range of encrypted predictions. So really there's more information at this is a reference, and there is a link which I've provided over here on if you'd like to get more information on how we can control super AI. Please visit this. The biggest problem that we are going to see is going to be the evidence in the labor market. There is already this example of where this company, this hotel, is trying out a towel delivering assistant. So actors, teachers, therapists, you would probably have competition from AI machines. So think again. Definitely jobs are going to be lost to AI, but my own thinking is that jobs will move to a new sphere where people will be able to build and use these AI tools to a larger benefit. So in summary, IoT will not work without AI. IoT needs AI and machine learning. AI and machine learning are a happening transformation. We are seeing AI already everywhere. Super AI is now possible. AI does have a dark side, but AI can be controlled by encryption so that it does not have negative impacts. And as you see, the proliferation of IoT devices and edge sensors, you can use AI to the benefit of human beings. So there are some references. I've given a reference over here at the end, please do read more at some of the collections of Stuart Russell from UC Berkeley. And that is all. I will now open it up to questions. Thank you, and I look forward to the discussions and interaction. And let's open it up in the chat box. What you were indicating, Shubham, indicates that logistics and navigation will have the maximum potential. I agree. Logistics and navigation would have a huge potential. Already we see examples of weak AI with the GPS navigating devices, and this would grow stronger and stronger as we see the use of super AI. So there is a comment by Edith. I think that health has the highest value. The value coded seems underestimating its worth. Okay. Yes, I know health has the maximum potential for AI, and that's the reason we see IBM Watson, which is announced there. Watson, H. mentioned that earlier. Watson is going to medical school, so IBM Watson is really training its system for learning about medicine because they see that business-wise the maximum potential will be in health. So if one adds to its new treatments and prevention of diseases in the older age, I agree. Have to define highest, I guess. Yes, I agree. But I also feel, according to McKinsey, the potential is going to be highest for factories and industrial IoT, where really you're seeing already so much of mechanization and automation, and with the industrial revolution, probably the immediate returns are going to be in the industry, in the factories. Does AI work best at GPU level or the cloud? So that's a good question. At GPU level, if you have a fast processing capability, I think it's best to have edge processing, because when you are sending data to the cloud, if you're sending images and videos to the cloud, you're going to take up network bandwidth. And when you are doing that, you are slowing down the response time. You are introducing latencies, and so you could have better processing capabilities, better modeled at the cloud. But if you, as you can see, with the edge processing and the compute capabilities at the edge, with finer processors, new capabilities, if you can do that at the edge, definitely it will be better, because now you do not have to rely on sending the data to the cloud. For example, what happens if the communication link broke down and you are not able to send data to the cloud? So then you are not able to have your inference. Whereas if you have at the GPU level, or if you have at the edge, then definitely you could take the benefit of that. So robots, for example, may not necessarily need to communicate to the cloud, and they would be self-reliant. So there's another question by C.Y. Leong. Is AlphaGo a new AI or a similar version of IoT AI? I need to check that. And is it a similar version of IoT AI? Let me check that out, and let's connect CY so that we can discuss this. I'm not sure. So Pradeep has asked a question: AI will change manufacturing industries? Absolutely. Or is that a comment? I think it's a comment. AI will change manufacturing industries. Yes, absolutely. I think that's where they're going to see the huge impact of AI, where probably there will be a loss in job for workers, where workers were part of the complete chain of operations. And of course, with IoT itself, there'll be a lot of automation. But as the automation comes in, it will require AI and machine learning. And so the jobs will probably shift to a new level, to a higher level, where rather than doing lower end, low skill jobs, people will have to move to jobs which require more intelligence and jobs which cannot be replaced by lower end AI. So I just checked out AlphaGo is a computer program that plays a board game, right? So and it is developed by Alphabet. That's Google's parent company, Google's DeepMind, and we need to see what are you thinking with the reference to IoT. Definitely find that interesting. We'll check it out. Wahid has a point: is GPU better than CPU on AI related algorithm, gigahertz and cores? How do we balance the benefit from them? I agree. I think that's the whole point, where you're looking at whether to have GPU or not, and that's a question. That's a point which Intel and NVIDIA have had, as a competing point amongst themselves, whether to have GPU or not, whether GPU is better than CPU. And I think definitely I agree, GPU would be better than CPU on AI-related algorithms. And that's what the Movidius, Intel Movidius, is basically based on, where it has a vision processing unit, which is, working on low power consumption and just, connects via the USB stick and has all the capabilities for the vision processing on the GPU itself, on the VPU itself. I will have the slides available through the admin, so you will get a copy. Thanks to all of you for attending this session. I hope you enjoyed.